Imagine waking up tomorrow and realizing that every single thing you thought you knew about Earth might not be just coincidence, but part of a deeper hidden pattern. Our planet feels ordinary because we live on it every day, but the truth is far stranger than we admit. Think about it. Of all the billions of stars scattered through the galaxy and the countless planets spinning around them, this one tiny blue sphere just happens to have the exact conditions needed for life. Not only that, but those conditions aren't just good enough. They are bizarrely perfect, almost as if someone or something carefully tuned the settings. Earth sits in a delicate cosmic balance, close enough to the sun to stay warm, but not so close that oceans boil away. It spins at the exact speed needed to maintain day and night, tilts at just the right angle to give us seasons, and carries a rare shield of magnetism that deflects lethal radiation. The more you pull at these threads, the more impossible it seems that all of this just fell into place by accident. And then there's the moon. That glowing companion in the night sky doesn't just give us tides, it stabilizes Earth's entire rotation, preventing catastrophic swings that could have erased the possibility of complex life. The chances of a planet our size having such a perfectly placed moon are astronomically low. Add to that the fact that water, the very liquid of life, has properties so unusual it defies simple chemistry. It floats when frozen, bends light, and regulates heat in ways no other substance does, almost like it was designed for one purpose: to make life possible. So when you start connecting these dots, a new picture emerges. Earth isn't just another rock drifting through space. It's an outlier, a mystery, a riddle written across billions of years. Some say it's all luck, others whisper it's a blueprint. But either way, one question refuses to go away. Is our home a cosmic accident? Or is there a secret design hidden beneath the surface of everything we see? The Earth is often described as the just right planet, sitting in what scientists call the Goldilocks zone. But when you stop and really think about what that means, it becomes almost unsettling. Our world isn't just a ball of rock orbiting a star. It is a delicate system where everything from the angle of sunlight to the thickness of the atmosphere fits together in a way that feels almost intentional. To live here is to take these conditions for granted, but if you compare Earth to any other world we've explored, the differences are staggering. Imagine Venus cloaked in choking clouds of carbon dioxide, where temperatures soar hot enough to melt lead, or picture Mars frozen and dry with an atmosphere so thin it can't hold on to heat, leaving the surface blasted by cosmic rays. Both planets orbit in the same neighborhood of our solar system, yet both are barren, lifeless wastelands, and right between them, Earth thrives. That alone is enough to make you pause. Why here, and why this exact balance? Our distance from the sun is often highlighted as one of the most crucial factors. Too close, and the oceans would have evaporated into a suffocating atmosphere like Venus. Too far, and everything would be locked in ice like Mars. Earth's orbit happens to fall within this incredibly narrow band where liquid water can exist. Water is the foundation of life, and without it, nothing we know could have emerged. But what's remarkable is that the zone itself is razor thin. A slight shift in Earth's orbital path, a little closer to the sun or a little farther away, and the balance collapses. It's like walking a tightrope strung across a bottomless pit. We don't fall, not because the rope is wide and forgiving, but because somehow we're balanced perfectly on the line. But distance alone isn't the full story. Consider the sun itself. Our star is unusually stable compared to many others we've observed. Stars are volatile, chaotic entities, prone to flares, violent radiation bursts, and instability that can sterilize nearby planets in seconds. Yet the sun, over billions of years, has maintained an unusual steadiness. Its energy output fluctuates, yes, but not in the wild, unpredictable swings seen elsewhere. That stability created a calm environment where life could evolve and endure. Without it, Earth might have experienced catastrophic freezes and boilings that wiped everything out before it could begin. It's another roll of the cosmic dice that came up strangely in our favor. And then we have the atmosphere, a shield and a lifeline wrapped around the globe. It's composed of just the right mixture, about 78% nitrogen, 21% oxygen, and small traces of other gases. That balance is extraordinary. Too little oxygen, and complex life could never have developed. Too much, and the planet would become dangerously combustible, where wildfires could rage uncontrollably. Yet Earth's atmosphere maintains that delicate ratio, feeding every breath we take while filtering harmful radiation and retaining just enough heat to keep the surface temperate. The greenhouse effect, so often cast as a danger today, is in its natural state precisely tuned to prevent Earth from freezing solid. If our world had the atmospheric setup of Mars, our oceans would be frozen blocks. If it had Venus's atmosphere, we'd be scorched beyond recognition. Instead, it's perfectly balanced. Even Earth's tilt contributes to the uncanny precision of conditions. Tilted at about 23.5 degrees, our planet spins in such a way that it creates seasons. That might sound simple, but it's critical. Without seasons, ecosystems would stagnate, and climate zones would be far less diverse. Seasons drive cycles of growth and rest, migration and renewal. They carve out the ecological variety that has given rise to the vast diversity of life. If Earth tilted much more, the weather would swing violently, with scorching summers and brutal winters that could destabilize life. If it tilted less, the planet would become locked in monotony, with less room for adaptation and complexity. Somehow, Earth tilts at the angle that fosters balance, resilience, and dynamism. Then there's rotation. A day on Earth lasts 24 hours, and that rhythm has profound consequences. Spin too quickly, and hurricane-force winds would tear across the surface. Oceans would slosh unpredictably, and life might never find a stable footing. Spin too slowly, and days and nights would stretch unbearably long, one side of the planet baking in endless sunlight, while the other freezes in eternal darkness. Instead, Earth rotates at just the right speed to create a cycle of light and dark that energizes ecosystems, fuels photosynthesis, and regulates body clocks in every living creature. The length of a day is so deeply embedded in life's DNA that it seems impossible to separate one from the other. Could life have developed with 100-hour days or frantic 4-hour ones? Perhaps, but it would look nothing like what we see here. When you zoom out and see all of these factors stacked together, the odds start to feel overwhelming. Distance, stability, atmosphere, tilt, rotation, all of them independent, all of them necessary, and all of them falling into place. Scientists call it fine-tuning, though even that phrase barely captures the magnitude of the puzzle. It's like flipping a coin not once but 1,000 times in a row, and having it land heads every single time. The rational part of us says it's possible, but at what point does possibility start to look like intention? The real kicker is that this balance hasn't just appeared, it has lasted. For billions of years, Earth has held on to this harmony. Other planets may have flirted with habitability in the past, but they lost it quickly. Mars, for example, once had rivers, lakes, and even oceans, but its core cooled, its magnetic field collapsed, and the atmosphere was stripped away by solar winds. In a cosmic blink, a potential cradle of life became a barren desert. Venus might once have had water too, but a runaway greenhouse effect boiled it all away, turning it into a pressure cooker of carbon dioxide. Earth alone kept its equilibrium, generation after generation, eon after eon. And perhaps the most haunting realization is that none of this had to be the case. Change any one factor, shift the orbit a fraction, alter the atmosphere slightly, slow the rotation by a bit, and the story of life would never have been written. There would be no forests, no oceans teeming with creatures, no human beings to stand here and marvel at the improbability of it all. Just another lifeless rock among countless others. But that isn't what happened. Against staggering odds, Earth became the stage where life not only appeared but flourished. So when we call this planet just right, it's more than a simple description. It's a phrase that hides layers of mystery. Why should it be just right at all? Why should all these variables, each one fragile, each one unlikely, come together in a way that creates a living, breathing world? Some would say it's luck, a fluke of physics and chemistry in a vast universe where every possibility eventually plays out. Others argue it hints at something deeper, a hidden order written into the laws of nature themselves. Whatever the answer, one truth remains. Earth is not ordinary. It is an exception, a cosmic riddle, and the more closely we look, the stranger it becomes. And as we peel back each layer of this mystery, the question only grows louder. If the first step of the puzzle is already this uncanny, what will the next steps reveal? Because the closer you look at our planet, the more the story twists from simple science into something far more unsettling. If Earth's position in the cosmos seems like a miracle, the concept of the Goldilocks zone makes it even more astonishing. Scientists use that phrase to describe the narrow band around a star where conditions might allow liquid water to exist on a planet's surface. Not too hot, not too cold, but just right. It sounds simple, almost like a children's story, but the reality is anything but. This so-called habitable zone is razor thin when you think about cosmic distances. Shift Earth a little closer to the sun, and oceans would have boiled away, leaving behind a dry wasteland like Venus. Move it just a little farther out, and the seas would have frozen solid, locking the planet into a perpetual ice age like Mars. Yet somehow, Earth is nestled right in that slim corridor of possibility. It's as if our world found the only sweet spot on an endless dial, and once it landed there, it held steady for billions of years. Venus is often called Earth's twin because it's nearly the same size and mass, but that's where the similarities end. With an atmosphere made almost entirely of carbon dioxide and surface pressures 90 times greater than Earth's, it's a suffocating inferno. Temperatures soar above 850 degrees Fahrenheit, hot enough to melt lead, making the surface one of the most hostile environments imaginable. The strangest part, Venus might not have always been that way. Some scientists believe it could have had oceans early in its history, maybe even mild temperatures, but a runaway greenhouse effect spiraled out of control, boiling the water away and trapping heat in a vicious feedback loop. Now it stands as a cautionary tale, a stark reminder of how fragile planetary balance really is. Venus exists just a little closer to the Sun than we do, but that slight difference changed everything. On the other side of us sits Mars, a planet that feels almost like the opposite of Venus. Thin atmosphere, frigid temperatures, and a surface scarred by ancient rivers and lake beds that long ago dried up. Mars too might have once been habitable. Evidence shows that billions of years ago, it had flowing water, maybe even seas. Yet the planet's smaller size meant its core cooled quickly, shutting down the magnetic field that once shielded its atmosphere. Without that protection, solar winds stripped away the air, leaving the planet exposed and barren. Today it's a world of dust storms and frozen deserts. Again, the difference is small. Mars isn't that much farther from the Sun than Earth, but the consequences are staggering. While our world blossomed with life, Mars became a graveyard of possibility. So when we talk about the Goldilocks zone, it's not just about being in the right place. It's about being in the right place at the right time, with the right conditions holding steady long enough for something as delicate as life to take root. Earth wasn't just lucky to land in the habitable zone, it managed to stay there while its neighbors fell into ruin. That raises questions that scientists still wrestle with. Why did Earth succeed where Venus and Mars failed? Was it purely chance, or is there something deeper hidden in the laws of nature? Part of the answer lies in Earth's balance of greenhouse gases. Without a certain amount of carbon dioxide, methane and water vapor, our planet would be an icy wasteland. But too much of these gases and we'd overheat like Venus. Earth's atmosphere regulates itself in ways that seem almost uncanny. Volcanoes release carbon dioxide, plants absorb it, oceans store it, and over geological timescales, the carbon cycle acts as a thermostat. When the planet gets too warm, weathering of rocks increases, pulling more CO2 out of the air. When it cools, the cycle slows, allowing gases to build up again. It's not a perfect system. It has faltered many times in Earth's history, but it has managed to hold conditions within a lovable range for billions of years. That's not something we see on Mars or Venus. Another factor is Earth's dynamic geology. Plate tectonics constantly recycle the crust, moving continents, building mountains, and regulating the carbon cycle by subducting and releasing gases. This restless motion of Earth's surface plays a key role in maintaining the climate. Without plate tectonics, the planet might have locked into one extreme or another. Venus has no active plate tectonics, and its surface is a scorched, stagnant wasteland. Mars had tectonic activity early in its history, but lost it as the planet cooled, leaving behind a frozen landscape dotted with the corpses of volcanoes. Earth alone continues to shift and churn beneath our feet, keeping the engine of habitability running. Even our orbit plays into this balance. Earth's path around the Sun is nearly circular, which keeps the amount of solar energy we receive relatively stable throughout the year. Compare that to other planets with more elongated orbits, where distances swing wildly, causing dramatic climate fluctuations. Earth's eccentricity is low, and that steadiness helps maintain conditions that life can rely on. It's another piece of the puzzle that seems almost too precise to be accidental. When scientists look for life beyond our solar system, they often focus on exoplanets in the habitable zones of their stars. Thousands have been discovered, but so far, none have shown the perfect cocktail of conditions Earth enjoys. Many are tidally locked, with one side perpetually facing their star, while the other remains in darkness. Others orbit red dwarfs that flare violently, blasting any atmosphere into space. Some are giant gas worlds with no solid surface. The more we learn about these distant planets, the more unusual Earth begins to appear. It's not just in the Goldilocks zone, it's in a Goldilocks situation, where multiple factors line up in ways that seem improbably rare. That rarity is what makes the question so haunting. Is Earth truly one of a kind, or have we simply not searched long enough to find its twin? If it is unique, then the implications are staggering. Life as we know it may be far more fragile and exceptional than we dare to imagine, and if life is rare, then intelligent life may be rarer still. That thought alone reshapes our understanding of our place in the universe. But for all the science, the emotional impact is what lingers. To realize that our existence depends on a narrow band of space, a careful mix of gases, a stable orbit, and a restless geology, it feels less like an accident and more like a story. Whether that story is written by chance, by natural laws, or by something beyond our comprehension is the great mystery. What we do know is that every breath we take, every step we walk, every moment we live, depends on a balance so fragile it could have easily tipped the other way, and yet it didn't. Against all odds, Earth held on to its sweet spot, and because of that, we are here to wonder about it. The Goldilocks zone is more than a scientific concept. It's a symbol of the razor's edge we walk on as a species, a reminder that our home is rare and precious. When you stand outside on a clear night and look at the stars, it's tempting to think that planets like ours are everywhere, waiting for discovery. But the truth is, even if they exist, none will ever be quite like this one. Earth is not just in the right place, it is the right place. And that realization forces us to look deeper at the coincidences that shaped our world, because the further we go, the more the line between coincidence and design begins to blur. And yet, as perfect as Earth's placement is, there's another piece of the story that's even harder to explain, something that doesn't just influence the planet, but controls it in ways we're only beginning to understand. Because while Earth might sit in the sweet spot of the cosmos, it owes much of its stability and life-giving rhythm to a companion that has been silently pulling the strings since the very beginning. The moon. When people look up at the night sky, the moon often feels like a simple companion, a pale disk hanging above us that waxes and wanes with comforting regularity. It has inspired poets, guided travelers, and been the backdrop to humanity's first steps beyond Earth. But the deeper you look into its influence, the more astonishing it becomes. The moon is not just a beautiful ornament, it is one of the most important stabilizing forces in Earth's history, and without it, the planet as we know it would be unrecognizable. The more scientists uncover about its role, the more it feels like this quiet neighbor might have been the single factor that kept Earth habitable long enough for life to flourish. Consider Earth's tilt. Our planet spins on an axis that leans about 23.5 degrees relative to its orbit. This tilt is the reason we experience seasons, the steady rhythm of change that has shaped ecosystems for millions of years. But here's the hidden truth, that tilt is not fixed. It wobbles, like a spinning top, influenced by gravitational forces. Without the moon, that wobble could have been catastrophic. Planets without large moons are prone to violent shifts in axial tilt, sometimes swinging dozens of degrees over relatively short geological timescales. Imagine Earth tilting not just a few degrees, but 40 or 50. One moment, the equator might scorch under relentless heat. The next, it could freeze in darkness while the poles bask in tropical warmth. Such instability would devastate ecosystems, making it nearly impossible for complex life to establish itself. Yet because of the moon's gravitational grip, Earth's tilt is held in check, oscillating gently within a narrow range. That stability has allowed climates to remain predictable enough for forests, oceans, and eventually human civilizations to rise. The moon also drives tides, one of the most profound forces shaping life on Earth. Tides might seem simple, water pulled by gravity, rising and falling twice a day, but their influence runs deep. Billions of years ago, tides created shallow, shifting pools along coastlines. In these tidal zones, early life may have found the perfect training ground. Organisms trapped in retreating waters were forced to adapt to fluctuating conditions, strengthening resilience and diversity. Some scientists argue that the constant ebb and flow of tides was crucial in pushing life out of the oceans and onto land. The rhythm of tides continues to govern ecosystems today, influencing migrations, feeding patterns, and breeding cycles. Every crashing wave and every retreating tide is a reminder of the moon's pull, a cosmic hand sculpting the very conditions for survival. But the story doesn't end there. The moon also acts as a brake, gradually slowing Earth's rotation. Billions of years ago, a day on Earth lasted only about 6 hours. The planet spun furiously, whipped around by its own momentum. Such rapid rotation would have created extreme winds, violent weather, and an environment far less stable than what we know today. The gravitational interaction between Earth and the Moon has been steadily transferring energy, slowing Earth's spin to the 24-hour day we now experience. That deceleration not only tamed the climate, but also created a rhythm of day and night that became deeply woven into the fabric of life. Circadian rhythms, the biological clocks inside every organism, are synced to this cycle. It is no exaggeration to say that the length of our days, the very cadence of our lives, is written into us because of the moon. And yet, the moon itself is a mystery. Its origin story reads more like science fiction than simple geology. The most widely accepted theory is that, in Earth's infancy, a Mars-sized body known as Theia slammed into our planet. The impact was so violent that debris from both Earth and the intruder was blasted into orbit, eventually coalescing into the moon. What are the odds of such a perfectly calibrated collision? Too small to calculate. If the impact had been weaker, no moon would have formed. If it had been stronger, Earth might have been shattered completely. Instead, the result was a companion of just the right size and distance to stabilize Earth and sculpt the conditions for life. It is the kind of cosmic accident that feels more like fate than randomness. The moon's size is another anomaly. Most moons in the solar system are tiny compared to their planets. Mars has 2 small potato-shaped rocks orbiting it, barely worthy of the title moon. Jupiter and Saturn have many moons, some large, but none of them dominate their planets the way ours does. Earth's moon is unusually large in proportion to its host planet, a true outlier among celestial companions. That size is exactly why it exerts such a powerful influence on Earth's tilt and tides. Without it, Earth would likely resemble Mars, cold, dry, and unstable. The coincidence is staggering. A random collision billions of years ago produced the perfect partner, a partner that would quietly ensure Earth's long-term stability. Even the moon's distance from Earth is uncanny. Over time, it has been slowly drifting away, at a rate of about 3.8 centimeters per year. That means billions of years ago, it was much closer, looming large in the sky, and creating massive tides. Today, it sits at just the right distance to create the phenomena we take for granted: total solar eclipses. Think about that for a moment. The sun is 400 times larger than the moon, but it is also about 400 times farther away, making them appear almost exactly the same size in the sky. This is a staggering coincidence. No other known planet has such a perfect setup, where its moon can completely cover its star in a breathtaking eclipse. To some, this is pure chance. To others, it looks like a signature, a deliberate alignment meant to provoke awe and wonder. The moon has also been humanity's first step into the cosmos. When humans set foot on its dusty surface in 1969, it wasn't just a triumph of engineering. It was a return of sorts, a reunion with the body that has shaped us since the beginning. The samples brought back revealed that the moon is chemically similar to Earth, supporting the collision theory, but even that deepened the mystery. If the moon came from Earth's crust, then in a strange way, it is a piece of us. Our planet and its companion are bound together by more than just gravity. They share a common origin, a shared fate written in ancient fire. What makes the moon's role so eerie is how easily it could have been different. If the Theia impact had not happened, Earth might have ended up a chaotic, unstable world. If the moon had been smaller, it wouldn't have been strong enough to stabilize our tilt. If it had been farther away, tides would have been too weak to shape early life. Yet somehow, all of these factors aligned. The moon became not just a companion, but a guardian, a silent partner in the grand story of life. When you put all this together, the moon stops being ordinary. It becomes extraordinary, almost uncanny in its precision. A giant impact that should have been disastrous instead produced exactly the right outcome. A moon that should have been too small or too distant turned out to be just large enough, just close enough, and just steady enough to make life possible. And all of this unfolded in a solar system where Venus burned, Mars froze, and no other planet found the same fragile balance. The next time you look up at the night sky and see the moon glowing softly above, it's worth remembering that it isn't just a silent rock. It is a cosmic architect, a stabilizer of seasons, a driver of tides, a regulator of time itself. Without it, we might not be here to look at all, and once you realize that, the question becomes harder to ignore. Was this just an accident of physics, or was there something more at work? Something that intended for Earth to have exactly the partner it needed? Because as strange as it sounds, the story of the moon makes the line between chance and design blur even further, leaving us to wonder whether our world's perfection is truly random, or whether it was written into the very fabric of the cosmos from the start. Long before Earth looked anything like the green and blue world we know today, it was a chaotic place, a ball of molten rock spinning violently in the void. The solar system itself was young, only a few tens of millions of years old, and it was a shooting gallery of planetary bodies colliding, merging and shattering in an endless dance of destruction and creation. Among those wandering giants was one roughly the size of Mars, a rogue world scientists have named Theia. Its path crossed Earth's in a way that would change the destiny of both forever. The collision that followed was one of the most violent events in the history of our planet, an impact so catastrophic it should have been the end. Instead, it became the beginning of one of Earth's greatest mysteries. When Theia slammed into Earth, the force was beyond comprehension. Imagine an object the size of an entire planet striking at more than 20,000 miles per hour. The collision released more energy than billions of nuclear bombs, melting vast swaths of Earth's surface and sending colossal plumes of vaporized rock into space. For a moment, Earth itself might have been reduced to a molten, churning mass, its surface glowing like the sun. From this chaos, chunks of Earth and Theia were blasted into orbit, forming a ring of molten debris circling the wounded planet. Out of that fiery ring, over time, the fragments coalesced, pulled together by gravity into a single body. That body became our moon. The odds of this playing out the way it did are almost impossible. A collision at a slightly different angle might have obliterated Earth entirely, scattering its remains across the solar system. A weaker impact might not have generated a moon at all, leaving Earth as an unstable, wobbling planet prone to wild tilts. Yet the collision occurred at precisely the angle and force needed to produce a large, stable moon, one massive enough to regulate Earth's axis and drive the tides. What should have been the destruction of a planet became the foundation of stability. Out of disaster came the perfect partner, as if chaos itself had rolled the dice and landed on an outcome that looks suspiciously like intention. The evidence of this ancient impact is still written in the moon itself. When astronauts brought back samples from the lunar surface, scientists discovered something startling. The isotopic composition of moon rocks is nearly identical to Earth's mantle. That suggests the moon is not some captured wanderer from elsewhere in the solar system, but a piece of Earth itself. Theia didn't just strike us, it merged with us, its legacy forever fused into the planet beneath our feet and the companion in our sky. In a strange way, the moon is Earth's twin, born of violence, carrying fragments of both worlds in its body. Every time we look up at it, we are seeing part of our own planet, hurled outward by a collision that rewrote our history. The consequences of that collision went beyond just forming the moon. It reshaped Earth itself. The impact likely stripped away part of the early atmosphere, setting the stage for the one we breathe today. It may have tilted Earth's axis into the position we now know, giving us the rhythm of seasons. It churned Earth's interior, helping to form the layered structure of core, mantle, and crust. Theia's iron core may even have merged with Earth's, boosting the dynamo effect that generates our protective magnetic field. In other words, this cosmic catastrophe didn't just create the moon, it set Earth on the path to becoming habitable. Without it, our planet might have been unrecognizable, a barren world spinning unstably, stripped of its shield, devoid of the conditions necessary for life. The more you think about it, the more the story begins to feel uncanny. In the chaos of the early solar system, countless collisions occurred, but none produced anything like Earth and its moon. No other rocky planet has a moon so large relative to its size. Mars's moons are tiny, captured asteroids, barely clinging to orbit. Venus has none at all. Mercury spins alone in silence. Only Earth bears the mark of such a cataclysm. and only Earth enjoys the stability that came from it. The moon is an outlier, a cosmic rarity, and its origin story is unlike anything else we've found. What are the odds that our one habitable world would also be the one with this bizarre, perfectly timed collision? The chances shrink the more you examine them, until the line between coincidence and something more deliberate starts to blur. Over time, the moon's presence began to shape Earth's destiny in subtle but powerful ways. Its gravitational pull slowed Earth's furious spin into the calm 24-hour day we now live by. Its tidal forces nurtured the earliest forms of life, creating the ebb and flow that pushed organisms to adapt and evolve. Its stabilizing influence prevented catastrophic tilts that could have plunged the planet into chaos. All of this traces back to that single collision, that single improbable event in a universe filled with chaos. A disaster that should have ended Earth instead became the key to its survival. There is a poetic irony in the fact that the moon, born from violence, became the guardian of stability. Without it, Earth might have been a world of extremes, swinging between ice ages and infernos, unfit for complex life. Instead, the moon gave us balance, rhythm, and time itself. It became a clock in the sky, its phases guiding ancient calendars, its cycles woven into the fabric of human culture. For countless civilizations, the moon has been a symbol of mystery and meaning, a celestial mirror reflecting not just sunlight, but our own fascination with the cosmos. Yet beneath the poetry lies a scientific reality. Without that ancient collision, without the moon, we might not be here at all. Even today, the legacy of Theia lingers. Some theories suggest that fragments of the ancient impactor still exist deep within Earth's mantle, strange anomalies that hint at a buried history. Others speculate that Theia may have delivered key materials like water or organic compounds that helped seed life. The idea that life itself might owe its existence to this violent collision adds another layer to the mystery. Was it pure chance that Theia struck Earth in exactly the right way to create conditions for life? Or is there something about the universe that nudges chaos into patterns, turning destruction into creation? When you piece together the story, it becomes difficult to dismiss as mere accident. A young planet, struck by a rogue world, survives and emerges stronger, more stable, and uniquely equipped to nurture life. Its shattered fragments form a companion that becomes its protector, its regulator, its silent partner across billions of years. Out of all the countless collisions in the solar system, only this one created such a perfect outcome. To call it coincidence feels almost like an understatement. It feels more like destiny. And yet, this is only one piece of Earth's improbable puzzle. The collision that gave us the moon also left Earth with another gift, one even more crucial to life's survival, a magnetic shield, invisible but indispensable, that guards us from the deadly forces of space. Without that shield, the sun's radiation would have stripped our atmosphere and sterilized the planet. With it, Earth became a sanctuary, but just like the moon, that shield exists because of strange and delicate circumstances that could have easily gone another way. If there is one invisible force that quietly guards every breath we take and every drop of water that flows across Earth, it is the planet's magnetic shield. Unlike the moon, you cannot look up at the sky and see it. Unlike the atmosphere, you cannot feel it on your skin or taste it in the air. And yet, without it, Earth would be unrecognizable. The magnetic field is the silent guardian of life, an unseen barrier standing between our fragile world and the relentless violence of space. What makes it even more uncanny is how rare and delicate this shield really is. In all the places we've studied across the solar system, no other planet seems to have one as strong and as perfectly tuned as ours. That fact alone raises unsettling questions about how much of our survival is chance, and how much might be something more. At the heart of this shield lies Earth's core. Deep beneath the crust and mantle, thousands of kilometers down, there is a churning ocean of molten iron and nickel. As this liquid metal moves, driven by convection currents and Earth's rotation, it generates electric currents. Those currents, in turn, produce a magnetic field, a planetary-scale dynamo that extends far into space. It surrounds Earth in an invisible cocoon, a magnetosphere that deflects the charged particles constantly streaming from the sun. Without this deflection, those particles, known as the solar wind, would strip away the atmosphere molecule by molecule. Over time, the planet would be left exposed, airless and dead, much like Mars. To understand how extraordinary Earth's magnetic shield is, you only have to look at what happened to our neighboring planets. Mars once had a magnetic field, Billions of years ago, when its core was still molten, it may have protected the planet in much the same way ours does today. Evidence of ancient riverbeds and oceans suggests Mars might have been a habitable world, perhaps even lush with water. But its smaller size meant that its core cooled quickly, and when the dynamo effect stopped, the shield collapsed, solar winds tore away the atmosphere, and the oceans evaporated into space. What remains is a barren desert, scarred by dust storms and radiation, a fossilized reminder of what happens when the shield goes down. Venus offers an even more brutal example. With no magnetic field to protect it, the sun's radiation ravages its upper atmosphere, driving away hydrogen and leaving behind a choking blanket of carbon dioxide. Both of Earth's closest neighbors lost their chance at habitability when their invisible guardians failed. Earth, however, kept its dynamo alive. Its core remains hot, its molten metal continues to churn, and the magnetic field persists. The sheer improbability of this endurance is striking. If Earth had been slightly smaller, its core might have cooled too quickly. If its rotation was slower, the dynamo might not generate enough force. Yet somehow, the balance was struck. Even the violent collision with Theia may have played a role. By merging with Earth, Theia's iron-rich core may have boosted Earth's own, keeping it molten and active for billions of years. Out of destruction came the very mechanism that would guard the atmosphere, the oceans, and eventually all life that would follow. The magnetic field does more than just protect. It also creates phenomena that remind us of its presence in the most beautiful way imaginable. The aurora, when charged particles from the sun are deflected by the magnetosphere, some are funneled toward the poles where they collide with molecules in the upper atmosphere. The result is a dazzling light show, curtains of green, pink, and violet dancing across the sky. To ancient peoples, these lights were messages from the gods, omens of war or fortune. Today we understand them as the visible fingerprints of Earth's shield in action. They are a reminder that, even though the magnetosphere is invisible, its power shapes the skies themselves. Yet for all its beauty, the magnetic field is not perfectly stable. It drifts, wobbles, and even flips. Over Earth's history, the poles have reversed many times, with north becoming south and south becoming north. These flips can take thousands of years, and during the process the field weakens. Even now, scientists have detected regions where the magnetic field is unusually weak, such as the South Atlantic anomaly, a zone where satellites passing overhead are bombarded by higher than normal radiation. These fluctuations serve as a sobering reminder that Earth's shield is not guaranteed forever. It is a living, shifting phenomenon, and if it were ever to collapse, the consequences would be catastrophic. The role of the magnetic field in enabling life cannot be overstated. Without it, ultraviolet and cosmic radiation would bombard the surface, mutating DNA and sterilizing entire ecosystems. The oceans might survive for a time, but the atmosphere would slowly erode until only a thin wisp remained. Unable to hold on to water, Earth would transform into a hostile wasteland, stripped of its blue skies and protective air. The magnetic field is not just an invisible force, it is the reason Earth is alive. Every forest, every coral reef, every city skyline exists because molten iron still churns deep below our feet, tirelessly sustaining the shield. The question then is why Earth's dynamo has lasted so long when others have failed. Some suggest it is simply luck. Earth was big enough to retain heat, and its rotation provided enough force to keep the molten metal moving. Others point to the Theia impact as a decisive factor, giving Earth an unusually large and active core. Still others wonder if the presence of plate tectonics, constantly cooling the mantle and recycling the crust, plays a role in maintaining the heat flow that drives the dynamo. Whatever the cause, the result is an improbable stability. Out of all the planets in our neighborhood, only Earth managed to keep the shield running, and only Earth managed to hold on to the delicate conditions life requires. It is humbling to realize how dependent we are on something so distant from our daily lives. When you step outside and breathe fresh air, you are not just relying on the trees or the oceans, you are relying on the shield that has kept that air from being stripped away. When you watch a sunrise or swim in the sea, you are living in the gift of protection granted by a magnetic field you cannot see. We are creatures of the surface, but our survival is tied to the fire and motion deep within the planet's heart. The dynamo is our lifeline, and without it, we would be nothing. This invisible protector also complicates how we think about life beyond Earth. When astronomers search for habitable exoplanets, They do not just look for worlds in the Goldilocks zone. They also consider whether those planets might have magnetic fields. Without one, habitability becomes fragile, temporary at best. A planet could be perfectly placed in orbit, rich with water and the right atmosphere, and still lose it all in a few 100 million years if the shield fails. Earth's example suggests that life requires more than just the right distance from a star. It requires a guardian, an unseen shield standing watch against the fury of space. That narrows the odds even further, making Earth's story not just rare but possibly unique. The more you think about it, the stranger it feels. An unseen shield created by molten metal deep underground, shaped by an ancient collision, lasting billions of years without faltering. A shield so perfectly tuned that it has kept us safe without us even noticing. To some, this is the beauty of chance, the improbable miracle of physics and geology lining up in just the right way. To others, it feels like something more deliberate, as if the shield were part of a blueprint written into Earth itself. Whatever the explanation, the truth remains the same. Without it, life would never have stood a chance. And that realization leads to another mystery. If Earth's survival depended on such a fragile chain of events, a collision, a molten core, a lasting dynamo, how many other planets could have replicated the same sequence? If the answer is almost none, then Earth may not just be rare, it may be one of a kind. That thought is both comforting and unsettling, because it suggests our place in the cosmos is more precarious than we dare admit. We are here because a shield holds back the chaos, and someday, if that shield falters, everything we know could unravel. For now, though, it continues its silent work, a guardian we cannot see, reminding us that even the most invisible forces can decide the fate of worlds. Once Earth had its shield in place and the chaos of its violent birth began to settle, the planet entered a phase of extraordinary calm, a stretch of time so stable it almost defies belief. In the grand theatre of the cosmos, where stars explode, comets smash into planets, and orbits shift unpredictably, Earth somehow found itself in a relatively quiet neighborhood. This calm, stretching over billions of years, became the backdrop against which life could take its tentative first steps, stumble, adapt, and eventually flourish into the complex web we see today. Without these long, peaceful eras, the story of life on Earth might have been interrupted before it ever had a chance to write its first chapter. To understand the importance of stability, it helps to look at what came before. In the earliest days of the solar system, Earth was constantly bombarded by asteroids and comets. This period, known as the Late Heavy Bombardment, was a storm of destruction that lasted hundreds of millions of years. The scars of that time are still visible on the Moon, where craters remain etched in silence, untouched by erosion. On Earth, the evidence has been erased by plate tectonics and erosion, but scientists know the bombardment was just as brutal, if not worse. Oceans boiled, the surface was shattered, and any fragile beginnings of life were likely annihilated over and over again. For a planet, survival in such conditions was nearly impossible. Yet once the bombardment tapered off, Earth emerged into something rare, a long, stable period in which impacts became fewer, climates moderated, and life had the breathing space it needed to take hold. It was during this calm that Earth's oceans stabilized, becoming vast reservoirs of liquid water stretching across the globe. Those oceans were not just scenery, they were crucibles. Within them, chemistry had time to experiment. Simple molecules collided, broke apart, and reassembled in endless combinations. Without constant catastrophic impacts wiping the slate clean, those molecules could persist, accumulate, and eventually stumble into the patterns we now recognize as the foundations of life. The calm provided time, and time is the most precious resource evolution has ever had. In chaos, complexity struggles to survive. In stability, it thrives. The geological calm also extended to climate. While Earth has certainly experienced ice ages, warm periods, and shifts in atmosphere over its history, these changes unfolded over millions of years, giving life time to adapt. Compare this to the instability of a planet without balance, where sudden swings in tilt or catastrophic atmospheric losses could erase ecosystems in a blink. Earth's relatively gentle rhythms allowed primitive organisms to spread, diversify, and explore new niches. From the first single-celled organisms to the explosion of multicellular life, each step required not just the right chemistry, but the stability to let those changes accumulate over deep time. Without billions of years of relative peace, Evolution could not have crafted the intricacy of forests, coral reefs, and human minds. What makes this calm so strange is that it wasn't guaranteed. Cosmic hazards lurk everywhere. Asteroids large enough to sterilize the planet still drift through space, their paths only slightly nudged by gravitational whispers from larger planets. Supernovae occasionally blast their surroundings with radiation strong enough to strip atmospheres and scorch life. Rogue stars and passing objects can destabilize planetary orbits, and yet Earth's place in the Milky Way has kept it away from most of these threats. We orbit in a relatively quiet region, far from the violent center of the galaxy where stars collide and radiation storms rage. Jupiter and Saturn, massive gas giants farther out, act as gravitational shields, deflecting or capturing many comets and asteroids that might otherwise have smashed into Earth. It is as though Earth exists in a sheltered pocket of the cosmos, a small harbor where life could quietly develop while storms raged elsewhere. Even when catastrophes did strike, they often became opportunities. The asteroid that wiped out the dinosaurs 66 million years ago is the most famous example. It was devastating, erasing 3/4 of species in a geological instant. And yet, because of Earth's resilience and stability, life bounced back. In fact, that destruction opened the door for mammals to rise, eventually leading to humans. Other mass extinctions followed similar patterns, disasters that seemed final but ultimately gave rise to new forms of life. This cycle only worked because Earth remained fundamentally stable beneath the chaos. The shield held, the climate eventually recovered, and the oceans remained. It was as if the planet could take the blows and keep moving forward each time, reshaping the story of life without ending it entirely. Think about the sheer scale of this timeline. Earth is 4.5 billion years old, and life began at least 3.5 billion years ago. That means for 3 billion years, microbes, algae, and simple organisms quietly multiplied, spread and experimented generation after generation, under a sky that remained steady enough for them to endure. If Earth had faced constant chaos, endless bombardment, wild climate shifts, the loss of its atmosphere, those fragile beginnings would have been snuffed out. Instead, the planet gave them time to adapt to oxygen when photosynthesis transformed the atmosphere, time to evolve into multicellular organisms during the Cambrian explosion, time to crawl onto land, sprout forests, and eventually build civilizations. All of this rests on the foundation of long, improbable calm. It's almost eerie to realize how many things had to align for this stability to exist. The magnetic shield protected the atmosphere from being stripped. The moon steadied Earth's tilt, preventing wild swings in climate. The position in the Goldilocks zone kept oceans liquid. The gas giants stood guard in the outer solar system, reducing the frequency of catastrophic impacts. Even the galaxy itself seems to have played a role, giving Earth a quiet orbit far from chaos. Each layer of protection, each stroke of luck, compounded into billions of years of peace. Not perfect peace, but enough. Enough to let life inch forward from chemistry to consciousness. And so we find ourselves here looking back at that vast calm, as if it were ordinary, when in reality it was anything but. Out of all the possible worlds, Earth is one of the few that found itself cradled in safety long enough for life to unfold. We live not just on a planet, but on a timeline, one gifted with the rarest of commodities, stability. When you measure existence against the violent backdrop of the universe, it begins to feel less like a coincidence and more like a story carefully written. Whether that story was carved by chance, by natural law, or by something greater, is a question that still lingers. What cannot be denied is that without those billions of calm years, nothing we see around us would exist. And yet, even in calm, the planet held surprises. The oceans where life stirred had properties that defy easy explanation, quirks of chemistry that seem almost tailor-made for survival. If the calm gave life time to grow, then water itself gave it the medium to thrive. But water is no ordinary substance, and the deeper you look into its strange behavior, the more you begin to wonder whether it is simply a liquid or a clue. For all the talk of orbits, shields, and cosmic collisions, there is one ingredient without which Earth would have remained a barren rock: water. It covers more than 2/3 of the planet's surface, cycles endlessly through oceans, rivers, clouds, and rain, and courses through every living being. It is so common here that we rarely stop to ask how strange it really is. Water is not just liquid, it is one of the most unusual substances in the universe, a chemical oddity with properties so bizarre that without them, life could never have taken hold. When you look closely at what water can do, the more it feels less like a simple compound and more like a hidden key written into the fabric of existence. To begin with, consider the most obvious property. Water expands when it freezes. Almost every other liquid in the universe contracts as it cools, becoming denser as molecules pack closer together. Water does the opposite. When it drops below 4 degrees Celsius, it begins to expand, forming the crystalline lattice of ice. That lattice is less dense than liquid water, which is why ice floats. At first glance, that might seem trivial, but it is nothing short of miraculous. If ice sank instead of floated, lakes, rivers, and oceans would freeze from the bottom up, locking entire ecosystems in ice that would never melt completely. Life in the oceans would suffocate under frozen ceilings, and the planet would become uninhabitable. Instead, because ice floats, it forms an insulating layer on top of water, protecting the liquid below and allowing life to persist, even in harsh winters. Entire species owe their survival to this one improbable quirk of chemistry. Water also has an unusually high specific heat capacity, meaning it can absorb and store large amounts of energy without changing temperature quickly. This single property smooths out Earth's climate. Oceans act as massive heat reservoirs, absorbing warmth in the summer and slowly releasing it in the winter, preventing the planet from swinging between scorching days and freezing nights. Without this buffer, climates would be far more extreme, and life would struggle to adapt. Think of deserts, where the absence of water leads to burning heat by day and freezing cold by night. Now imagine that kind of volatility covering the whole planet. Life would have no stable foundation. Instead, water's ability to moderate temperature created an environment where ecosystems could establish themselves and thrive. Then there's water's role as a universal solvent. It is capable of dissolving more substances than any other liquid known. This ability allows nutrients, minerals, and gases to move freely through organisms and environments. Inside cells, water dissolves salts, sugars, and proteins, carrying them to where they are needed. In rivers, it dissolves minerals from rocks, transporting them to the oceans. Without this property, the chemistry of life would grind to a halt. Complex reactions that require dissolved molecules bumping into each other would be impossible. Life would never have moved beyond the simplest chemical reactions. Instead, water created a stage where complexity could emerge, grow, and eventually evolve into biology. Another remarkable property is water's surface tension, one of the highest of any liquid. This tension comes from hydrogen bonding between water molecules, creating a kind of invisible skin at its surface. Surface tension allows tiny organisms to walk across ponds, lets droplets form and cling to leaves, and helps water climb through the thin tubes of plants in a process called capillary action. Without it, plants could not draw water from roots to leaves, and forests would never exist. It's a small, invisible force, yet it shapes entire ecosystems. Imagine a world without trees, without grasses, without the plants that form the basis of food chains. That's what Earth might look like without water's peculiar stickiness. Even more bizarre is water's triple point, the unique temperature and pressure at which it can exist simultaneously as solid, liquid, and gas. On Earth, conditions fall perfectly within the range that allows all three states to coexist in abundance. We have ice, liquid oceans, and water vapor in the air, all constantly transforming into one another. This endless cycle drives weather, nourishes crops, and keeps climates balanced. In contrast, on Mars, water is mostly locked away as ice or released as fleeting vapor, while on Venus, any liquid water boiled away long ago. Earth sits in the rare pocket where water cycles endlessly, sustaining life at every step. The strangeness goes deeper still. Hydrogen bonding, the same force behind water's surface tension, also gives it an unusually high boiling point. Without these bonds, water would boil at temperatures far below what we experience on Earth. Our oceans would evaporate into space, leaving the planet dry. Instead, hydrogen bonds keep water liquid across a wide temperature range, providing the stable environment life needs. It is as though water was tuned not just to exist, but to persist under the exact conditions Earth offers. And then there's the mystery of where water came from in the first place. Early Earth was a molten ball, far too hot to hold on to water. So how did oceans form? The leading theories suggest water was delivered by comets or water-rich asteroids that bombarded Earth in its early years. Another possibility is that volcanic activity released water vapor trapped in minerals, which then condensed into rain. Either way, the sheer volume of water on Earth is puzzling. Our planet is far wetter than most others in the solar system, raising the question of why it was singled out for this abundance. Did Earth simply get lucky, positioned at the right distance to capture and hold water, or was there something more deliberate about how it was supplied? For billions of years, water has been the thread connecting every stage of life's story. Microbes thrived in tidal pools shielded by the ebb and flow. Fish evolved in the ocean's depth, adapted to the unique properties of buoyancy and pressure. Plants pulled water from the ground, reaching for sunlight and creating the oxygen we breathe. Humans themselves are mostly water, carrying the same properties that shaped our world within our very bodies. Every heartbeat depends on it. Every breath is sustained by the plants and oceans that rely on it. Water is not just an external environment, it is us. The more we study water, the more unsettling its strangeness becomes. It is as if this simple molecule, made of only 2 hydrogen atoms and 1 oxygen, was designed with life in mind. It defies the normal rules of chemistry again and again, in ways that all converge toward making Earth habitable. Ice floats, oceans regulate climate, molecules dissolve, plants drink, weather cycles and bodies live. If even one of these properties were different, life might not exist, and yet every single one of them works in harmony, as though water was built for this role. It is easy to overlook water's oddity because it surrounds us, but in cosmic terms it is rare. Worlds across the solar system are dry, icy, or scorched. Even when water is present, it is locked away or fleeting, unable to sustain the cycles that make Earth unique. Our planet is drenched, overflowing, alive, and that life depends not just on the presence of water, but on the bizarre, almost miraculous properties of the substance itself. So when you stand by the ocean and watch the waves roll in, you are not just looking at water, you are looking at a mystery. You are looking at a liquid that defies expectations, one that seems tuned to the very idea of life. Whether by chance or by design, water is not ordinary. It is a puzzle, a whisper from the universe that survival is not random, but something written into the molecules themselves. And once you recognize how strange it really is, you begin to see the bigger question. If even water feels engineered for life, then what does that say about everything else that makes Earth possible? For all the wonders of Earth's placement in space, the protection of its shield and the strangeness of water, none of it would matter without the most mysterious substance of all, DNA. At first glance, it is nothing more than a microscopic thread, a twisting ladder of molecules coiled tightly within the cells of every living thing. But inside that thread lies a language, a code so precise and so universal that it governs everything from the tiniest bacteria to the vast complexity of the human brain. DNA is not just chemistry, it is information, and the existence of such a code raises questions that science has only begun to touch. Because if water provided the stage for life, DNA wrote the script. Deoxyribonucleic acid, the long name that hides behind the simple acronym, is built from just 4 chemical letters: adenine, thymine, cytosine, and guanine. Arranged in different sequences, those letters form instructions, not unlike the ones and zeros of computer code. From those instructions emerge proteins, enzymes, and the machinery of life itself. What makes this so astonishing is that the same 4 letters build everything. A single bacterium, a blade of grass, a whale, and a human being. All of them are constructed from variations of the same alphabet. It is a language that seems to transcend species, a script shared across the entire planet, as though life was written from a common book. The sheer efficiency of DNA is mind-bending. Each strand contains billions of these letters, coiled so tightly that every cell in your body holds an entire encyclopedia of instructions. If you stretched out the DNA in one human cell, it would be about 2 meters long. Multiply that by the trillions of cells in a single body, and the total length of your DNA could wrap around the Earth millions of times. And yet, all of that fits inside the nucleus of cells too small to see with the naked eye. It is as if information itself has been distilled into the smallest possible form, packed into a medium that life can copy, repair, and pass down through generations. What makes DNA even more astonishing is its accuracy. When cells divide, DNA is copied letter by letter. Errors happen, of course, but the system includes proofreading and repair mechanisms. tiny molecular editors that fix mistakes before they cause damage. This means the information is preserved with remarkable fidelity, generation after generation. A butterfly today carries the same code as its ancestors millions of years ago, with only minor changes. Humanity itself is built from DNA passed down through countless lifetimes, a thread that stretches unbroken through the entire history of life. It is a continuity that no human invention has ever matched. A library that not only stores knowledge, but actively uses it to create living beings. And then there is the universality of it. Across all known life, DNA uses the same code. The same sequences of letters mean the same things in bacteria as they do in humans. This suggests that life has a single origin, one root from which everything else has branched. But it also raises an unsettling question: why this code? Out of all the possible ways to store and transmit information, why did the universe settle on this one? Scientists have speculated about alternative chemistries, or even completely different molecules that could in theory carry information. Yet everywhere we look, on every branch of the tree of life, the same DNA is there. It is as if the code was chosen once, long ago, and has never been replaced. Some call it the frozen accident. Others wonder if it was more than that. The structure of DNA itself is a marvel. The double helix, first revealed by Watson and Crick in 1953, is not just elegant, but functional. Each strand carries a mirror of the other, meaning that if one is damaged, the other can serve as a template for repair. The ladder-like structure allows the molecule to unzip during replication, with each half guiding the reconstruction of its partner. It is self-preserving, self-correcting, and self-replicating, a system so sophisticated that it borders on the uncanny. When James Watson first saw the model, he reportedly muttered, "It's too pretty not to be true." And indeed, the symmetry and efficiency of the helix seem almost artistic, as if the blueprint of life had been written with both function and beauty in mind. But DNA does not act alone. The information it holds is useless without the machinery to read it, transcribe it, and translate it into proteins. Within each cell, a molecular factory carries out these steps with astonishing precision. RNA acts as the messenger, copying sections of DNA and delivering them to ribosomes, which then translate the sequence into chains of amino acids. Those chains fold into proteins, the workhorses of biology, forming enzymes, structures, and signals that keep life running. It is a process so intricate that it makes even our most advanced technology look primitive. A single cell, invisible to the eye, contains more complexity than any machine humans have ever built. And all of it operates according to instructions written in DNA. What is most unsettling is the origin of the code. How did molecules stumble into a system so sophisticated, so efficient, and so universal? Chemistry can explain how nucleotides form, how they might link into chains, how they can replicate with the right conditions, but the leap from chemistry to code remains one of the greatest mysteries in science. Random molecules do not usually organize themselves into libraries of information. The fact that DNA exists at all is like discovering that rocks on a beach have arranged themselves into a novel. Was it pure chance, played out across billions of years of chemical trial and error? Or does the universe have an inherent tendency toward order, a hidden structure that nudges chaos into pattern? DNA also raises questions about destiny. Because it mutates, the code is not static. Errors creep in, sequences change, and over time, evolution uses those changes to create new forms of life. In one sense, DNA is a script that constantly rewrites itself, generating new chapters without end. But in another sense, it feels like the story was already baked in. The possibility is encoded from the beginning. The same code that gave rise to bacteria also contained the potential for dinosaurs, redwood trees, whales, and humans. It is as though all of life was waiting within those 4 letters, unfolding across time like a secret gradually revealed. Think of the odds. Out of the countless combinations of molecules, Earth ended up with one that acts like a programming language. It is digital in its precision, with sequences of bases functioning almost like binary code. It is redundant enough to correct errors, flexible enough to create infinite variations, and compact enough to fit inside every living cell. It is not just chemistry, it is information processing on a cosmic scale. Some scientists marvel at this as the greatest achievement of evolution, but others whisper that it looks suspiciously like design. Either way, It is a phenomenon that continues to challenge our understanding of what life really is. And then there is the personal connection. Every person alive today carries DNA that is 99.9% identical to every other human. That tiny 0.1% is what creates all the diversity of faces, talents, and personalities. Within your body, strands of DNA inherited from ancestors stretch back through countless generations. You are, quite literally, the latest edition of a story billions of years in the making. The same letters that once spelled out the instructions for single-celled organisms now compose the complexity of your own body. When you look in the mirror, you are not just seeing flesh and bone, you are seeing the expression of a code that has been carried forward without interruption since life began. DNA is, in many ways, the ultimate paradox. It is simple in its components, yet infinitely complex in its outcomes. It is universal across life, yet unique in every individual. It is fragile, subject to mutation and damage, yet resilient enough to endure billions of years. It is chemistry, yes, but also language, information, and memory. To encounter it is to face a mystery. Why does life need a code? And why is the code so improbably perfect? Perhaps that is the most haunting realization of all. DNA is not just a molecule, it is a message. Whether that message arose by accident or was written deliberately is a question no one can answer, but it is impossible to deny that it is there, running through every cell, binding all of life together in a single story. And once you realize that life is built on information, not just matter, it changes the way you see everything else. It suggests that existence itself is not random chaos, but something structured, patterned, maybe even intentional. And if DNA is the script of life, then perhaps the universe is the author. If DNA is the code of life, then the proteins and structures it creates are the machines, engines, and factories that turn information into reality. When scientists first peered into the cell with the help of powerful microscopes and biochemical tools, they expected to see something crude, simple blobs of chemistry blindly reacting. What they found instead was a universe of machinery, complex beyond imagination, where every piece is fitted, folded, and orchestrated with a precision that rivals the most advanced human engineering. To call these systems biological machines is not metaphorical exaggeration. It is the most accurate description we have. They move, they transport, they construct, they repair, and they do it all at scales so small they make nanotechnology look primitive. And every single one of these machines emerged not from deliberate human design, but from the silent instructions of DNA. Take the ribosome, for example. It is one of the most fundamental machines in life, the workshop where proteins are built. Ribosomes read the instructions carried by RNA, stringing together amino acids in precise order, like a factory assembling components on an assembly line. Each ribosome is a complex molecular structure composed of proteins and RNA molecules folded together in intricate shapes. They are so efficient that a single ribosome can build thousands of proteins every hour, never missing a beat, never confusing the order. Imagine a machine smaller than a speck of dust that can outpace the most advanced factories we've ever constructed, and you begin to understand the scale of the miracle. Without ribosomes, DNA would be silent, like a book no one knows how to read. With them, the code becomes flesh, and life itself comes into motion. Then there are the enzymes, tiny molecular tools that catalyze the reactions of life. Chemistry on its own is slow and sloppy. Reactions that could take centuries in a test tube happen in milliseconds inside a cell. Because enzymes speed them up with jaw-dropping precision, they fold into unique three-dimensional shapes, with pockets and grooves perfectly suited to grab specific molecules. An enzyme doesn't just push a reaction forward, it selects, guides, and stabilizes it with the care of a master craftsman. The result is a level of control that ensures life runs smoothly, avoiding chaos while maximizing efficiency. The sheer diversity of enzymes is staggering. They cut DNA, stitch it back together, build cell walls, digest food, copy information, and repair damage. Every second you are alive, trillions of enzymatic reactions are happening in your body, each one perfectly tuned. Without them, life would be impossible. Inside the cell, there are also motor proteins, literal walking machines that move cargo along microscopic tracks. Imagine a protein shaped like a pair of legs, carrying tiny packages of molecules on its back, striding purposefully across a filament. This is not science fiction. It is happening inside you right now. One famous motor protein, kinesin, takes steps about 8 nanometers long, hauling vesicles filled with materials from one end of a cell to another. Under a microscope, it looks uncannily like a little creature walking, each step powered by the energy molecule ATP. These machines transport neurotransmitters to the ends of neurons, deliver building materials to cell membranes, and keep the cell supplied with what it needs. Without them, cells would collapse into chaos. They are living couriers, tirelessly walking along highways too small for the eye to see. Another marvel is ATP synthase, often described as one of the most efficient machines in the universe. Its job is to produce adenosine triphosphate, or ATP, the energy currency of life. This machine looks like a tiny turbine embedded in cell membranes. As ions flow through it, the turbine spins, literally rotating like a motor. With every turn, it manufactures ATP molecules, which power almost every biological process in existence. The scale is mind-bending. The average human body contains trillions of these turbines, and together they produce the equivalent of your body weight in ATP every single day. That means every thought, every heartbeat, every breath, and every step is fueled by the work of microscopic machines spinning tirelessly within your cells. If they ever stopped, life would end instantly. Even the cell membrane itself is a masterpiece of machinery. It is not just a passive barrier keeping the inside in and the outside out. It is an active, dynamic structure filled with channels, pumps, and sensors. Some proteins act as gates, opening and closing to allow ions to pass in and out. Others act as receptors, detecting signals like hormones or neurotransmitters and triggering responses inside the cell. The membrane constantly shifts, reshapes, and rebuilds itself, a living skin that is as intelligent as it is protective. The more scientists study it, the more it looks like an interactive control panel, finely tuned to keep life in balance. Perhaps the most astonishing of all are the molecular machines involved in DNA itself. Helicase is a protein that unwinds DNA, spinning like a motor to separate the strands so they can be copied. DNA polymerase is another, crawling along the strands like a microscopic craftsman, adding bases one by one to build a new copy. These machines work together in massive complexes, with multiple proteins cooperating in perfect choreography, ensuring that the code of life is faithfully passed on. Watching them under advanced imaging is like peering into a factory more precise than anything human engineers could conceive. It is humbling to realize that every cell in your body contains these machines, working ceaselessly to preserve your very existence. What makes all this so baffling is how it came to be. Machines, in our experience, are designed, factories are built, engines are engineered, and motors are crafted with intention. Yet in the cell, machines exist without designers, emerging through evolution over billions of years. Some scientists see this as the greatest testament to the power of natural selection. Given enough time, chance, and variation, complexity can emerge that looks indistinguishable from design. Others look at the same structures and feel the weight of another possibility, that the machinery of life is too precise, too elegant, to be the product of randomness alone. Regardless of interpretation, the fact remains that every organism, from the simplest bacterium to the most complex human, is filled with machines that defy ordinary explanation. Even more uncanny is the fact that these machines are self-assembling. Proteins fold themselves into the correct shapes, guided only by the sequence of amino acids encoded in DNA. Imagine ordering a box of parts for a car, dumping them on the ground, and watching them spontaneously fold, twist, and click together into a functioning engine without a single mechanic. That is what happens in the cell, every moment, billions of times over. Proteins know where to fold, when to connect, and how to function, without any external guidance. The precision is so extraordinary that scientists still struggle to predict protein folding with complete accuracy, despite massive advances in computing. And yet, life does it effortlessly, trillions of times a second. To witness these processes through the lens of science is to stand at the edge of wonder. The cell is not just alive, it is mechanical, computational, and chemical all at once. It is an entire city filled with machines working in harmony, each one vital, each one purposeful. The more you zoom in, the more extraordinary it becomes. The fact that such complexity exists in the smallest units of life is almost unbearable to comprehend. We think of technology as a human achievement, but long before humans ever existed, nature had already crafted machines at scales and efficiencies that put our inventions to shame. And that raises the question, is life itself a kind of technology? Is DNA a programming language, and proteins the hardware it builds? If so, then biology is not just an accident of chemistry, but a demonstration of something far deeper, a structure in the universe that creates order out of chaos, machines out of molecules, purpose out of randomness. Some will say this is simply evolution's masterpiece. Others will whisper that it looks like engineering. But no matter which view you take, the truth remains awe-inspiring. Every living being is filled with machines so perfect, so intricate, and so relentless that they blur the line between the natural and the design. Perhaps that is why, when scientists describe the cell, they often fall into metaphors of cities, factories, and engines. There is simply no other language that does justice to the scale of its complexity. Life is machinery, and machinery is life. And once you understand that, it changes how you see yourself, not as a single organism, but as a walking universe of machines, all working together to keep you alive. When you look at life closely enough, something strange begins to emerge. Patterns. Not random patterns, not messy coincidences, but shapes and sequences that repeat across scales, across species, even across the entire fabric of existence. Spirals, ratios, branching forms, and symmetries that appear in seashells, in galaxies, in DNA, and in the way rivers carve their paths. It is as if nature has a hidden geometry, a secret language of design that whispers through everything. People throughout history have called these sacred patterns, and whether you see them as the product of mathematics, evolution, or something more mysterious, their presence cannot be denied. They are everywhere, quietly unifying the living and the non-living into one coherent tapestry. Perhaps the most famous of these is the Fibonacci sequence, a series of numbers where each is the sum of the two before it. 1, 1, 2, 3, 5, 8, 13, and so on. On paper it looks simple, even dull, but when you translate those numbers into ratios, you discover the golden spiral, a curve that expands outward, yet maintains its shape. That spiral appears in sunflowers, where seeds pack themselves to maximize space. It appears in the swirling shells of snails and nautiluses. It appears in hurricanes and galaxies. Even the cochlea in the human ear follows the same curve. Why would such a pattern appear in such different places, from the smallest flowers to the largest galaxies? Some argue it is efficiency. The spiral distributes growth evenly, wastes no space, and balances forces. But others see something deeper, a universal blueprint, as though life and matter alike were written by the same hand. Fractals are another example, patterns that repeat themselves at different scales. Look at the branching of a tree. The trunk splits into branches, the branches into twigs, the twigs into leaves, and within the leaves, even the veins repeat the branching. The same pattern exists in rivers splitting into streams, in lightning bolts cracking through the sky, in the bronchi of your lungs carrying air into smaller and smaller passages. Zoom in or zoom out, and the form repeats, echoing itself across dimensions. Mathematicians call these fractals, but mystics see them as evidence of an underlying order, a reminder that the same laws govern the vast and the minute. It is as though the universe cannot help but echo itself, endlessly repeating its favored design. Symmetry is another universal rule. Butterflies spread wings that mirror each other, just as human faces strive for balance between left and right. Snowflakes fall with sixfold symmetry, each one unique but all following the same principle. Even subatomic particles carry symmetrical properties, obeying hidden laws that physics is still unraveling. Why does symmetry appeal so deeply to our senses? Why does it dominate life's architecture? Perhaps because symmetry is stability. A symmetrical body is more efficient to build, more resilient against damage, more balanced in motion. Evolution favors it, but so does the universe itself, carving balance into everything from flowers to galaxies. One of the strangest sacred patterns is found in DNA itself. The double helix, beyond being a molecule, is a spiral staircase, a repeating geometry that echoes the same spirals seen in shells and galaxies. The code of life is not just chemical, it is geometric. Proteins fold into precise three-dimensional structures that obey mathematical rules of symmetry and balance. Even at the molecular level, life seems to obey patterns written into the very structure of reality. Then there is the golden ratio, often denoted by the Greek letter phi, approximately 1.6118. This ratio has fascinated thinkers for centuries because it appears in art, architecture, and nature alike. The proportions of the Parthenon in Athens echo it. Leonardo da Vinci embedded it into his sketches of the human body. In nature, the golden ratio defines the spirals of shells, the growth of plants, even the proportions of the human face. What makes it haunting is that it is not just aesthetic. It seems to emerge naturally when systems grow in balance. Too small, and growth stalls. Too large, and systems collapse. At the golden ratio, things thrive. Why would mathematics align so perfectly with beauty, and why would both align with survival? It suggests that what we call beauty may simply be our recognition of harmony, a resonance with the deep mathematics of the universe. Even sound and vibration reveal sacred patterns. Somatics, the study of visible sound waves, shows that when vibrations pass through a medium like water or sand, they create intricate geometric shapes. Circles, hexagons, mandalas change the frequency, and the patterns change, but always with symmetry and order. These shapes look eerily similar to the designs in sacred art from cultures around the world. Mandalas from India, geometric tiling from Islam, Celtic knots from Europe. Were ancient cultures tapping into this hidden resonance without knowing it? Or did they intuitively sense the patterns that vibration creates? After all, at the deepest level, everything in the universe vibrates. Atoms, molecules, even space itself. Perhaps all form is simply frozen vibration, somatic patterns carved into matter. Water, too, seems to echo these sacred designs. When frozen into snowflakes, water always forms six-sided crystals, each one unique but bound by symmetry. When studied under certain conditions, liquid water can even form structured patterns, fleeting but ordered. Considering water's role in life, this is almost poetic, life's most essential substance, constantly revealing order hidden in chaos. It reinforces the sense that the universe is not random noise, but an orchestra playing melodies we can glimpse if we know how to listen. Biology, mathematics, and art converge on these patterns in ways that are difficult to dismiss as coincidence. Why should the spiral that governs the distribution of seeds in a sunflower also describe the shape of galaxies? Why should the branching of neurons in your brain echo the branching of rivers or lightning? Why should the ratio that makes a shell beautiful also guide the structure of hurricanes? Skeptics will say these are simply efficient solutions that nature stumbles upon again and again. But even efficiency begs the question, why are these solutions written into the very mathematics of reality? Why should the universe have rules that favor beauty, harmony, and repetition? Cultures across the world have noticed these patterns for millennia, long before modern science. Ancient Egyptians built pyramids with proportions aligned to the golden ratio. Hindu and Buddhist mandalas mapped the universe through repeating geometry. Indigenous peoples painted spirals, fractals, and branching lines into their art, reflecting what they saw in nature. To them, these patterns were not just aesthetic, they were sacred, glimpses into the order behind existence. Perhaps they intuited something we are only now beginning to confirm with mathematics and physics, that life is not random but patterned, and those patterns are clues. What is most striking is how these patterns appear in us as well. The human body itself is a masterpiece of geometry. Our DNA spirals, our faces follow golden ratios, our lungs branch fractally to maximize air exchange. Our heartbeat follows rhythmic cycles that mirror oscillations in nature. Even our brainwaves vibrate in frequencies that echo patterns in sound and light. We are not separate from the sacred geometry of the world. We are expressions of it, living examples of the patterns woven into reality. And perhaps that is the ultimate revelation of sacred patterns. They blur the line between the natural and the divine. You do not need to believe in mysticism to feel awe when you see the Fibonacci spiral in a nautilus shell, and realize it is the same spiral guiding galaxies. You do not need to believe in destiny to feel wonder when you realize your heartbeat, and the branching of a tree follow the same fractal laws. Whether you see it as mathematics, evolution, or design, the truth remains. Life is patterned, the universe is patterned, and we are part of that tapestry. In the end, sacred patterns remind us that we are not living in chaos, but in harmony. Even when things seem random, the deeper structures reveal order, repetition, and meaning. Perhaps these patterns are simply the fingerprints of physics, or perhaps they are something more, a glimpse into the mind of the universe itself. Either way, they give us something rare, a sense that everything is connected, from the swirl of galaxies to the curl of a fern, from the shape of your DNA to the storm raging across Jupiter. All of it is bound together by hidden geometry, by sacred patterns that refuse to stay hidden once you start looking. The more you study Earth and life, the harder it becomes to ignore how many coincidences had to align for any of this to exist at all. Scientists call it fine-tuning, the improbable precision of conditions that seem almost custom-made to allow life. At first glance, the universe appears vast and indifferent, a place of exploding stars, frozen wastelands, and inhospitable radiation. And yet here we are, alive on a planet that balances on a razor's edge, where every detail, big and small, fits together like pieces of a puzzle. The deeper you look, the more uncanny those coincidences feel, as if existence itself is the result of an impossible series of wins in a cosmic lottery. Start with Earth's position in the solar system. It orbits within what scientists call the habitable zone, the thin band of space around a star where temperatures allow liquid water to exist. Too close, and oceans would boil away like they did on Venus. Too far, and water would freeze solid like on Mars. Earth sits in that narrow Goldilocks zone, neither too hot nor too cold, just right for oceans, rain, rivers, and life. A small shift inward or outward, and the story would be radically different. But the coincidence doesn't stop there. Earth's orbit is nearly circular, keeping its distance from the Sun relatively stable. Its tilt, stabilized by the Moon, gives us seasons without swinging to wild extremes. Its rotation is fast enough to keep the planet from baking in daylight or freezing at night, yet not so fast that winds and storms would be catastrophic. Each of these details is delicate, each one balanced on the edge of possibility. The Sun itself is another coincidence. Not all stars are stable, but ours is unusually calm. Many stars flare violently, blasting nearby planets with radiation that sterilizes surfaces and strips atmospheres. The Sun, by contrast, burns steadily, its fluctuations small enough that life could adapt. It is also the right size. A smaller star would burn cooler, forcing the habitable zone to shrink so close that planets would likely be tidally locked, with one face scorched and the other frozen. A larger star would burn hotter and faster, leaving too little time for life to evolve before the star died. Somehow we ended up orbiting a star that is both steady and long-lived, giving Earth billions of years of stability. Even the composition of Earth's atmosphere feels suspiciously tuned. It contains about 21% oxygen, enough for complex life to thrive, but not so much that fires consume everything. If oxygen levels were significantly lower, larger and more active organisms might not be possible. If higher, ecosystems could collapse into flames. The balance of nitrogen, carbon dioxide, and trace gases also plays a crucial role, regulating climate and sustaining plant life. It is a cocktail so precise that even small changes would render the planet hostile, yet it has held within survivable ranges for eons, even as Earth went through ice ages, volcanic eruptions, and asteroid impacts. Then there is water, the strangest coincidence of all. Earth not only has water, but has exactly the right amount. Too little, and the planet would be a dry wasteland with life struggling in tiny oases. If at all, too much, and Earth would be a water world, its surface drowned under endless oceans with no land for complex ecosystems to form. Instead, Earth has a balance, oceans covering much of the surface, but land rising above them, creating the diversity of environments life needs. Add to this water's bizarre properties, its ability to dissolve nutrients, its expansion when frozen, its regulation of climate, and you begin to see how improbable the balance really is. Look deeper into physics, and the coincidences become even more staggering. The fundamental forces of the universe, gravity, electromagnetism, the strong and weak nuclear forces, are set to values so precise that even the tiniest variation would unravel everything. If gravity was slightly stronger, stars would burn too hot and fast, collapsing before planets could form. If weaker, stars would not ignite at all, leaving the universe dark and lifeless. If the electromagnetic force were different, atoms would not form the chemistry needed for molecules. If the strong nuclear force varied even a fraction, the elements essential for life, carbon, oxygen, nitrogen, might never exist. The odds that all of these constants align to allow life are so vanishingly small that some physicists argue the only explanation is either infinite universes, each with different values, or something beyond chance altogether. Consider carbon itself, the backbone of life. Carbon atoms can form long chains and complex structures, making the diversity of molecules that biology requires, but carbon's abundance is not inevitable. It is the result of a precise resonance in the way stars fuse elements. If that resonance were slightly off, carbon would be rare or non-existent. Without carbon, no DNA, no proteins, no plants, no people. The same goes for oxygen and nitrogen. The fact that stars produce exactly the right elements in exactly the right abundances feels less like an accident and more like the universe preparing ingredients for life. Even the presence of the moon adds to the fine-tuning. Our moon is unusually large compared to Earth, and its gravitational pull stabilizes the planet's tilt. Without it, Earth's axis might wobble chaotically, leading to extreme climate shifts that could make complex life impossible. The moon also drives tides, which not only shaped coastal ecosystems but may have played a role in the origin of life itself, creating tidal pools where chemistry could flourish. The impact that created the moon was violent and destructive, but its outcome left Earth uniquely stable and fertile. Once again, disaster became destiny. And then there is Jupiter, the giant guardian of the solar system. Its massive gravity acts like a shield, deflecting comets and asteroids that might otherwise slam into Earth with devastating frequency. While impacts still occur, the rate is low enough that life can recover and continue evolving. Without Jupiter's protection, Earth might have been bombarded into sterility. It is a silent guardian, orbiting far away, shaping Earth's safety without us ever noticing. The more you stack these coincidences together, the harder it becomes to dismiss them. The right star, the right orbit, the right tilt, the right rotation, the right atmosphere, the right amount of water, the right chemistry, the right moon, the right neighbors in the solar system, the right constants in physics, each one improbable, each one essential. Alone, any of these could perhaps be explained as chance. Together they form a chain so precise that it begins to look intentional. It is like rolling dice and hitting the same winning number not once but again and again, billions of times in a row. At what point does chance stop feeling like a sufficient explanation? For some, these coincidences are the strongest argument for a multiverse. If infinite universes exist, each with different laws of physics and different arrangements of matter, then perhaps it is inevitable that one of them would be just right for life. We just happen to live in that one because we could not exist anywhere else. For others, the coincidences point toward design, as if the universe was set up with life in mind. Between those views lies mystery, the kind that humbles even the most confident scientist, because whether by infinite chance or purposeful design, the fact remains, the universe seems suspiciously good at making life possible. On a personal scale, the fine-tuning is easy to overlook. We breathe, we drink, we walk under the sun, and it all feels ordinary. But step back, and the ordinariness dissolves. Every breath is possible only because oxygen sits at the right concentration. Every sip of water is possible only because of its strange chemistry. Every sunrise is possible only because Earth orbits in a narrow band around a calm star. These are not small coincidences. They are the foundations of existence. The fact that they all align in one place at one time for billions of years is perhaps the most astonishing fact of all. And so we find ourselves staring at the improbable chain of fine-tuned details, wondering if it is truly coincidence. Perhaps it is chance stacked upon chance. Perhaps it is the hidden necessity of physical laws. Or perhaps it is something else, something that points beyond the boundaries of science. Whatever the explanation, the truth is the same. Existence is fragile, improbable, and precious. And the more you recognize the razor's edge we live on, the more miraculous it feels to be here at all. For all the improbable conditions, strange substances, and hidden patterns that make life possible, nothing is as bewildering as the fact that life became aware of itself. Consciousness stands apart as the great mystery, the phenomenon that science can describe in fragments but not explain in essence. You can map brain activity, trace neural circuits, and measure electrical signals, but none of that explains why there is an experience inside. Why should matter, organized in a certain way, suddenly have thoughts, feelings, and awareness? Why does the firing of neurons feel like joy, sorrow, memory, or imagination? Out of all the puzzles Earth offers, this is the most intimate and the most haunting. How does the universe produce a mind capable of knowing it exists? Consider what consciousness actually is. It is not just intelligence, not just problem solving or reaction. A computer can solve problems, a calculator can compute, and artificial intelligence can mimic language, but they do not feel. You, by contrast, are aware. You are not just processing information, you are experiencing it. The redness of a sunset, the taste of salt on your tongue, the ache of nostalgia when you hear an old song, these are not just signals traveling through neurons. They are qualia, the raw texture of experience. Science can trace the pathways, but it cannot explain why there is something it feels like to be you. That gap, known as the hard problem of consciousness, is one of the deepest unsolved mysteries in all of knowledge. Evolution offers a partial story. Consciousness likely began as simple awareness, the ability of organisms to detect light, heat, touch, and danger. Over time, brains grew more complex, layering perception with memory, anticipation, and self-awareness. An animal that can feel pain avoids harm. An animal that can imagine danger avoids it before it happens. Awareness in this view is an evolutionary advantage, honed by survival. But even if that explains why consciousness might evolve, it does not explain why it feels like something to be alive. Why should evolution produce not just behavior but inner experience? Survival does not require beauty or love or curiosity. Yet here we are feeling all of those things. The human brain, the most complex structure we know of in the universe, is the seat of this mystery. With roughly 86 billion neurons, each connecting to thousands of others, it creates a network of unimaginable density. Signals race along those pathways at incredible speeds, creating patterns that correlate with thought, perception, and memory. Neuroscience can show that certain brain regions light up when you recognize a face or solve a puzzle. It can trace how electrical signals turn into speech or movement, but the leap from activity to experience remains unexplained. How does the buzzing of neurons create the vividness of color, the richness of music, the depth of love? Matter alone does not seem sufficient to explain mind. Some thinkers argue that consciousness might be fundamental, woven into the universe like space, time, and energy. This view, known as panpsychism, suggests that awareness exists at some level in all matter, and complex brains simply amplify it into the rich experiences we know. Others argue that consciousness emerges only when matter reaches a certain threshold of complexity, a property that arises like wetness from water molecules. Still others lean toward mystery, admitting that our current frameworks may be too limited to grasp something so foreign. After all, the brain is trying to understand itself, and perhaps that is the ultimate paradox. The strangeness of consciousness grows when you consider imagination. You can close your eyes and conjure images that do not exist. You can imagine futures that have not happened, relive past moments, and even create worlds in dreams. No other phenomenon we know of does this. Matter on its own does not imagine. Yet here is the universe, through us, daydreaming about itself. That power has reshaped the planet, from the building of cities to the writing of symphonies. It has given rise to art, science, and philosophy, all expressions of consciousness reflecting on its own existence. Even stranger is the question of free will. Are our thoughts and decisions the result of genuine choice, or are they predetermined by the firing of neurons and the chemistry of the brain? Neuroscience experiments suggest that the brain begins preparing for decisions milliseconds before we become aware of them. Does that mean free will is an illusion, a story consciousness tells itself after the fact? Or is there something deeper, something irreducible about the feeling of agency? Either way, the mystery remains unsolved. We experience ourselves as free, even if the science is still undecided. Consciousness also blurs the line between inner and outer worlds. Your brain does not experience reality directly. It interprets signals from your senses, constructing a model of the world. Light hits your eyes, sound vibrates in your ears, molecules touch your tongue and nose, and electrical signals travel into your brain. From these fragments, your mind assembles a seamless picture of reality. The colors you see do not exist outside you. They are interpretations of wavelengths. The sounds you hear are your brain's translation of vibrations. Even your sense of self, the I you feel at the center of everything, is a construct, an ongoing narrative woven from memory and perception. Consciousness is not just awareness, it is a storyteller, crafting reality moment by moment. What makes this even more haunting is that consciousness is both fragile and enduring. A small injury to the brain can erase memory. distort personality, or extinguish awareness altogether. And yet, consciousness can expand beyond the limits of the body. Through language, writing, and culture, we have externalized thought, storing it in books, art, and now digital networks. Ideas outlive individuals, consciousness extending across generations. In this sense, awareness is both deeply personal and strangely collective. You are shaped by the thoughts of those before you, and your thoughts ripple into the future, long after you are gone. Dreams are another enigma of consciousness. Each night, without effort, your brain generates entire worlds. You walk through landscapes that do not exist, speak to people who are not there, and experience emotions so vivid they can linger after waking. Some scientists see dreams as the brain's way of processing memories, pruning information, and solving problems. Others see them as evolutionary training, rehearsals for survival. But beyond their function, dreams reveal the raw creativity of consciousness. Even in sleep, the mind cannot help but generate experience. It suggests that awareness is not just about reacting to the world, but about constantly creating new ones. Perhaps the greatest mystery of consciousness is its relationship to the universe itself. Out of billions of stars and planets, Earth produced beings capable of not just surviving but reflecting, questioning and wondering. Through us, the universe looks at itself. Through us, matter becomes aware. This raises questions that border on the philosophical or spiritual. Is consciousness an accident, or is it the point? Is awareness the universe's way of knowing itself, a necessary outcome of complexity? Or is it something more, a clue that reality itself is suffused with mind? Whatever the answer, consciousness changes the way we see existence. Rocks and rivers, stars and galaxies, all of it could exist without anyone to witness. But with consciousness, existence gains meaning. The sunset is not just light scattering through air, it is beauty. The forest is not just carbon and water, it is wonder. Music is not just vibration, it is emotion. Without awareness, the universe is silent. With it, the universe sings. And so consciousness stands as the most baffling coincidence of all. Out of dust, fire, and chemistry came thought. Out of atoms came imagination. Out of blind forces came awareness of beauty and sorrow. The fact that you can read these words, reflect on them, and even disagree with them is proof of the greatest mystery we know. Life became conscious, and in doing so, transformed the universe from a place of matter into a place of meaning. The story of Earth and humanity has so far been one of survival, adaptation, and discovery, but the next chapters remain unwritten. The future of our planet and our species is both fragile and vast, teetering between possibilities that inspire hope and those that provoke unease. For billions of years, Earth has endured cosmic collisions, climate swings and extinctions, and yet it's remained a cradle of life. Humanity, on the other hand, has existed for only a flicker of that timeline, yet in that short span we have reshaped the surface of the planet, bent rivers, lit up the night, split the atom, and sent machines beyond the solar system. The question now is not whether Earth will survive, it almost certainly will in some form, but whether we will, and what kind of legacy we will leave behind. One certainty is that Earth's climate and ecosystems will continue to change. They always have. Ice ages came and went, forests rose and fell, and seas advanced and retreated long before humans existed. But now, for the first time, a single species has gained the power to accelerate and direct those changes. Our industries release carbon dioxide that warms the atmosphere, alters rainfall, melts glaciers, and raises seas. Our technologies deforest landscapes, drain wetlands, and push countless species to the brink. The balance that made Earth habitable remains intact, but it is under strain. The choices we make in the next centuries will ripple across millennia. If we continue on a path of carelessness, the Earth will adapt, but perhaps not in ways that favor us. The biosphere does not negotiate, it shifts, collapses and rebuilds according to its own rule. Humanity may survive those shifts, or it may find itself swept away, a brief chapter in a much larger story. At the same time, the future is not only a tale of warnings, it is also one of unprecedented possibility. Never before has a species had the power to not only adapt to the world, but to reshape it consciously. We have the tools to heal ecosystems, to restore forests, to shift our energy to the endless supply offered by the sun and the wind. We can engineer crops resilient to harsh climates, purify water for billions, and perhaps even slow or reverse some of the damage already done. The very same technologies that threaten stability could become the instruments of renewal if guided by wisdom. In this sense, the future of Earth and humanity is not predetermined. It is an open field, and we are the gardeners. But the future also stretches beyond Earth itself. For most of history, humanity was bound to this planet, living under the same stars, never imagining that we might leave. Now we stand at the threshold of space, sending rovers to Mars, telescopes to the edges of the cosmos, and probes beyond the solar system. In the coming centuries, humans may become a multiplanetary species, building colonies on the Moon, Mars, or even farther afield. To some, this is a necessity, a way to ensure survival if Earth becomes uninhabitable. To others, it is destiny, the natural next step in evolution. If life arose against impossible odds on this one planet, then perhaps its purpose is to spread, carrying consciousness into the stars. Still, leaving Earth will not be easy. Our biology is tied to this planet's air, gravity, and cycles. Mars is hostile, with thin air, cold deserts, and relentless radiation. Other planets and moons are even harsher. Yet, with persistence and ingenuity, we may adapt, building domes, generating atmospheres, or even altering our own DNA to survive. Such a future raises unsettling questions. What will it mean to be human if our descendants evolve to live on other worlds? Will we remain one species, or diverge into many, shaped by different environments and technologies? The very concept of humanity may expand in ways we can hardly imagine. Even as we look outward, the future of consciousness itself may transform. Advances in genetics, neuroscience, and artificial intelligence are blurring the line between biology and technology. Already we can edit DNA, altering the instructions of life. Already machines can learn, mimic, and create in ways that once seemed exclusive to humans. In the future, will consciousness extend into machines? Will we merge with our creations, augmenting our minds, until the boundary between human and technology dissolves? Such possibilities sound like science fiction, but they are fast becoming science fact. The question is not whether they are possible, but whether we are ready to handle the responsibility they carry. The Earth, meanwhile, will continue its own journey. In about 1 billion years, the sun will grow brighter, heating the planet to the point where oceans may boil away. In 5 billion years, the sun will swell into a red giant, engulfing or scorching Earth beyond recognition. These cosmic fates are inevitable, but they are so distant that they feel almost unreal. What matters more is the near future, the centuries and millennia in which humanity must decide what role it wants to play. Will we be caretakers of the planet, living in harmony with its rhythms, or will we be exploiters, consuming until there is nothing left? Will we remain bound to this world, or will we carry Earth's story into the cosmos? There is also the question of meaning. For much of history, humans looked at the stars and felt small, fragile in the face of a vast, indifferent universe. But consciousness changes that. We are not just observers, we are participants. The universe has produced beings capable of reflecting on their own existence, of asking where they come from and where they are going. That awareness gives us responsibility. The future of Earth and humanity is not just about survival. It is about whether we can rise to the gift of consciousness and use it wisely. Will we create a future filled with beauty, compassion, and wonder, or one scarred by greed, conflict, and destruction? The choice is ours, and it may be the most important choice ever made on this planet. And yet, even in the face of uncertainty, there is reason for awe. Consider how improbable it is that we are here at all. Out of billions of stars, billions of years, and countless chances for failure, Earth became a sanctuary. Life not only survived, but grew, evolved, and became self-aware. That story is extraordinary, and it is still unfolding. The future is not written, but it is waiting for the decisions, the dreams, and the imagination of humanity. In the end, perhaps the greatest miracle is not that life arose, but that it continues and that it looks forward with curiosity and hope. The Earth will go on. Seas will rise and fall. Mountains will crumble. Forests will spread and vanish. Whether humanity endures alongside it depends on how well we understand the fragile chain of conditions that made existence possible. If we treat the planet with reverence, If we learn to see ourselves as part of its living system rather than its masters, then perhaps we will thrive for millennia to come. If not, Earth will recover, as it always has, but without it. The universe does not guarantee survival. It offers the chance, and the rest is up to us. And so, the future of Earth and humanity is a mirror. In it, we see not destiny, but possibility. We see warnings written in climate and extinction, but we also see potential written in knowledge, technology, and imagination. We see the fragility of life, but also its resilience. We see the vastness of space, but also the intimacy of awareness. The mirror shows us everything we could become, and everything we could lose. The only certainty is that time moves forward, and with it, the story continues. Whether that story is tragedy or triumph, is a question only we can answer. When you trace the story of Earth from its violent birth to the rise of consciousness, a question begins to emerge, one so vast and elusive that it has haunted humanity since the first sparks of thought. Why? Why is there something instead of nothing? Why does the universe produce stars, planets, oceans, DNA, and minds that can ask questions? Why do the laws of physics balance so perfectly, allowing matter to form, life to grow, and awareness to bloom? Science explains the how atoms bond, how stars ignite, how evolution sculpts complexity, but the why remains outside its reach. This ultimate question hovers at the edge of knowledge, too immense to capture and too important to ignore. For some, the answer lies in chance, in an infinite cosmos, or in a multiverse where countless universes bubble into existence with different laws. At least one would inevitably allow life. We live in that one because we could not live anywhere else. From this perspective, there is no deeper meaning. Life is simply the outcome of probabilities, rare but not impossible, like a winning lottery ticket in an endless game. The universe does not intend, it does not plan, it simply, we are observers in a vast machine, briefly awake before returning to silence. And yet chance alone feels unsatisfying to many. The odds stacked against life are so immense, the coincidences so precise, that randomness seems like a thin explanation. It is not just that Earth exists in a habitable zone, or that water has the right properties, or that DNA encodes information. It is that all of these align together in one place, at one time, for billions of years. The improbability is overwhelming. To look at this chain of conditions and call it luck feels like ignoring the weight of the question. It is not just improbable, it feels intentional, as though the universe were tuned for life, as though the script was written long before we appeared to read it. This sense of design has led many throughout history to see purpose woven into existence. Religious traditions speak of creation, of a mind behind the cosmos, of life as the expression of intention rather than accident. In this view, the universe is not indifferent, but alive with meaning, and consciousness is not a fluke but a clue. Our awareness, our ability to ask why, is evidence that we are part of something larger, something that wanted to be known. But even within faith, the mystery deepens. Why create a universe through such immense violence, through supernovas and extinctions, through billions of years of silence before life appeared? Why write meaning into a process that looks so much like chaos? If existence has purpose, it is not obvious, not simple, and not easily explained. Between chance and purpose lies another possibility, that meaning is not given but made. Perhaps the universe is neither random nor deliberate, but potential. Matter, energy, and laws create the canvas, but life paints the picture. Consciousness brings meaning into being. In this sense, the universe does not ask why, it asks us to answer. Every story, every song, every discovery, every act of kindness becomes the reason, not imposed from outside, but created from within. Meaning is not a property of matter, it is the gift of awareness. Without us, the stars shine, but no one marvels. With us, the stars become beautiful, and beauty itself becomes part of the universe. Still, the ultimate question resists closure. Even if meaning is made, why should the universe allow it at all? Why should atoms form stars, stars form planets, and planets foster life that can reflect on beauty? Why should existence be structured in such a way that self-awareness is even possible? Every answer leads to another question. Every explanation pushes the mystery back one step further. Even if the universe is infinite, why should there be anything infinite at all? Even if life arose from chemistry, why should chemistry exist in the first place? Why is there something rather than nothing? Perhaps the real mystery is not just why life exists, but why the question exists. Rocks do not ask. Rivers do not wonder. Stars do not contemplate. Only consciousness questions itself, and in that questioning reveals something astonishing. The universe has become self-aware. Through us, reality looks at itself and asks why it is here. That act of asking may be the closest we come to an answer. Perhaps the point of existence is not a final explanation, but the journey of awareness seeking itself, the endless unfolding of curiosity. There is also the possibility that the ultimate question cannot be answered in the way we want. We expect explanations to be like equations or stories, neat and complete. That existence may not fit into human categories. It may be too vast, too strange, too beyond our grasp. Asking why might be like asking what lies north of the North Pole. A question that feels natural but assumes the wrong framework. In that sense, the mystery is not a flaw but a feature. The fact that we cannot pin down the why may be the invitation itself to live in wonder, to recognize that existence is not a problem to be solved but a reality to be experienced. And yet, despite its resistance, the question pulls at us. It is the quiet weight behind art, religion, philosophy, and science. It is why we look at the stars with longing, why we build temples and telescopes, why we write stories about gods and galaxies. The search for why is woven into the fabric of humanity. It may never be answered, but it shapes us all the same, driving us to imagine, to create, to connect. In that way, the question is already an answer. It reveals what kind of beings we are, beings who cannot stop seeking meaning even in the face of silence. In the end, perhaps the ultimate question is not about the universe, but about us. Why do we care? Why do we feel awe at sunsets, fear at death, hope in the face of uncertainty? Why do we insist that life must have meaning, even when meaning is elusive? That insistence, that hunger for purpose, may itself be the clue. It suggests that awareness is not content with survival alone. It demands more. And whether that demand is met by a cosmic design, by the act of creating meaning ourselves, or by embracing mystery, it is the heart of what makes us human. So the story of Earth, of life, of consciousness, all funnels toward this final enigma: why? The question hangs like a shadow and a light at once, unanswerable yet irresistible. Perhaps someday we will understand more, perhaps not. But even if the answer remains forever out of reach, the asking itself matters. To ask why is to step outside instinct, to transcend mere survival, to touch the edge of the infinite. And maybe that is the point, that in asking the ultimate question we become part of the ultimate mystery. Looking back across the sweep of Earth's story, from its fiery beginnings to the rise of consciousness, and the mysteries that still hang unanswered, one truth becomes clear: existence is not ordinary. It is fragile, improbable, and astonishing at every turn. Our planet is a sphere of stone and water hanging in the vast darkness, yet it somehow became alive. From dust came oceans, from oceans came cells, from cells came minds capable of questioning the stars. Every step in that chain was unlikely, yet each one happened, and the result is you, here reading, wondering, alive. To see it all as random chance feels incomplete, but to see it as destiny feels overwhelming. Perhaps it is both, or something beyond either, a dance of accident and necessity, chance and pattern, chaos and order, woven together into a story too intricate to fully grasp. What we do know is that none of this was guaranteed. Earth could have frozen solid or burned dry. Life could have faltered in its infancy. Evolution could have stalled before consciousness. Any number of disasters might have erased the fragile beginnings before they had a chance to grow, yet they did not. Against every odd, existence continued, adapting, persisting, and reaching higher. And now, in the blink of cosmic time, we find ourselves in a position no species has held before, aware not only of survival but of the story itself. We are not merely passengers on this planet, we are its narrators, its caretakers, its only known voice in the void. That realization carries both wonder and weight. Wonder, because it means we are part of something miraculous, the living expression of a universe that became aware. Weight, because it means the future depends on the choices we make. Earth will endure, but whether it remains a home for humanity is not guaranteed. The balance that sustains us is delicate, and the same awareness that allows us to marvel at existence also gives us the power to destroy it. We have split atoms, burned forests, and altered climates, yet we have also written symphonies, healed diseases, and built machines that touch other worlds. Our legacy will depend on which path we choose more often: destruction or creation, neglect or stewardship. The conclusion, then, is not closure, but invitation. The mysteries of water, DNA, fine-tuning, and consciousness may never be fully solved, but they are not meant to paralyze us. They are meant to awaken us to how precious life is, how extraordinary this planet is, how miraculous it is that we are here at all. To live with that awareness is to live differently, to see oceans not as resources but as wonders, forests not as obstacles but as guardians, other people not as strangers but as fellow travelers on a fragile world. If there is an ultimate meaning, perhaps it is not hidden in the stars but written in how we choose to treat each other and the earth that made us. So the story circles back to the beginning, not with an answer but with a question. What will we do with the time we have? We cannot change the fact that stars will one day burn out or that Earth will one day be gone, but we can change how we live now. We can choose to fill existence with beauty, compassion, curiosity, and courage. We can choose to honor the miracle of being alive, and maybe, just maybe, that choice is the point. Not to solve the mystery of why we exist, but to live in such a way that existence itself becomes the answer.